guys, today we're doing 6.8, solving quadratic equations. So this is the first time you're doing it. We're in other polynomial equations using factoring method or the zero product property. The zero product property is something you're familiar with. You've been using it for a long time. The homework is page 289, 1 through 65 odd. You can skip 55 through 60. And let's get started. Our vocabulary for the day is zero product property, our roots, and our zeros. So we will get into those as we start learning about them. Okay, so solving quadratic and other, meaning it can be to the third power, it can be to the fourth power, so it's not just quadratics. So let's talk about solving equations. When we used to solve equations, I'd get something like this. My goal would be to isolate the variable. I add 10 to both sides using my properties of equality, then divide both sides by 5. Division property of equality, and I get x equals 2. Okay? Here, what we're going to do is, now that we know how to factor, we are going to solve the equation, and so here we go. What can be factored on the left side? Left side, we can take a GCF of x out, and then I'm left with x times x minus 5 equals 0. So we're going to use something that you've probably been using for years. It's called the zero product property. You might not have known the name. So, and that is, let's say I have something that looks like this, 5x equals 0. Well, we all know that x has to be 0 because anything, when you multiply two factors together and you get 0, you know that either of those factors has to be 0. Well, we're going to use that idea here, and we're going to set, since we don't know what both of our factors are, we're setting them both equal to 0 because one of the two could be the solution. And we set both factors in the in the equation equal to 0. So x equals 0 and x minus 5 equals 0. And then we solve. The first one is done. It's 0. And the second one, to solve it, to get the x alone, I would add 5 to both sides. And I end up with basically plus 5, x equals 5, right? And we have x equals 0. So we have two solutions when we're solving a quadratic. We have two solutions. And that is 0 and 5. Unless it's a perfect square trinomial, you're going to have two solutions when you're solving a quadratic. Okay? The only kind you won't would be a perfect square trinomial because those two factors are the same thing. So again, we factor it, we set both factors equal to 0, and then we solve those two equations. Now we call this the zero product property, whether we're doing factor times factor equals 0 or 5 times x equals 0. We know that in this case x has to be 0. Here we have two possibilities since we don't know what they are, if it's x and x plus 5, since there are both variables in both of those factors. Okay, so we know one of those, so x times 0 would equal 0, and x plus 5 times 0 would equal 0. So that's what we're doing. We're setting them both equal to 0. And my solutions. Now, this is what we call the solutions that we get. This is what we call our roots. They can also sometimes call them your zeros, not because it equals 0 here, but because we use the zero product property. So they might say find your zeros or find your roots. which 55 through 60, it says find the roots. It's basically just factoring, and we set it equal to 0. So find your roots or your zeros. That's what your solutions are when we set them both factors equal to 0. All right, let's get started. Let's try it. So on number 1, we're going to set each factor equal to 0. And then we're going to solve. And I do expect you to, we're going plus 4. We expect you to show work. X is equal to 4. Show properties of equality. How do you get there? Subtract 7, x equals negative 7. And then we're going to see our solutions are negative 7 and 4. Okay. Try the next one on your own. Pause the recording. Now let's check our work. We're going to set x equal to 0 and x plus 3 equal to 0. This one's already done. I'm going to subtract 3 and x equals negative 3. So I put them in a solution set, the braces, and I get negative 3 and 0. And again, the order doesn't matter. It's not an ordered pair. But in math, we usually go from small to big. Now you'll notice we have 3 factors. So on number 3, we have to set all 3 to 0. So 3x equals 0, x minus 1 equals 0, and x plus 4 equals 0. You do have to write this, by the way, and you have to show how you get to the answers. And x equals 0. Add 1. X equals 1. Subtract 4. And x equals negative 4. So we have 3 solutions. Negative 4, 0, and 1. Okay? And remember, these solutions do not go in parentheses. Okay, now this last one, let's take a minute and see if you can try that one on your own. Now let's check our work. X equals 0 and 2x minus 5 equals 0. Okay, this one's done. So here I have to get my 5 alone, my x alone. So I get 2x equals 5 divided by 2, and x is equal to 5 over 2. So my solutions are 0 and 5 over 2. And you can leave it in that reduced improper form. All right, let's try it again. Let's move on and get a little deeper. I'm going to skip this because this is pretty repetitive. Let's try some more. Okay, so now here's where the real stuff's happening. You'll notice you have a trinomial on the left side of your equal sign, so we are going to have to, and I do want to see you doing your x marks a spot, what multiplies to negative 12 and adds to negative 4. I guess I would kind of put it here. What multiplies to negative 12 and adds to negative 4. So I'm factoring, it would be negative 6 and 2. So I'm doing square root of x squared is x times x. I've got plus 2 and minus 6 equals 0. So I set them both equal to 0. Subtracting. And my solutions are negative 2 and 6. All right, Do you want to try the next one on your own? Might be a little tricky, but try it. Now let's check it. Okay. I'm going to erase this here. I do like to see you setting, but you do need to set both equal to 0. Do not just go for this. You need to set both equal to 0 and show your properties. All right, so the first thing I wanted to say is that remember when we're factoring, we always have to check for a GCF. And this has a GCF of 5. And so what I'm left with is, oh, not just 5, 5x. Right? And so what we're left with is x squared plus 4x plus 3 equals 0. So I have to do my x marks a spot here. What multiplies to 3 and adds to 4? They're both positive. Let's try 3 and 1. Okay, so I've got 5x and then x squared. I got to do an x and an x and a plus 1 and plus 3 equals 0. So now my three factors are 5x equals 0. X plus 1 equals 0, x plus 3 equals 0. Okay, divide both sides by 5, x equals 0, subtract 1, x equals -1, subtract 3. I'm using my properties of equality, x equals -3, and here we go. Our three solutions here are -3, -1, and 0. Okay? I do expect to see when you set them equal to 0, solving those equations. All right, why don't you pause the recording and try the next two on your own. Now let's check our work. On the first one, we've got x, and we've got, we can factor out the GCF, x squared minus 100 equals 0. You need the parentheses there. I can factor that further because that's what we call a difference of squares. It's x plus 10 times x minus 10 equals 0. And remember, we have to bring down everything else. Oh, let me go back here. Oh, no, not there. Sorry. Okay, so I've got three factors. X equals 0, x plus 10 equals 0, and x minus 10 equals 0. This is complete. I'm subtracting 10. X equals -10. I'm adding 10. X equals 10. So my three solutions are 0, -10, and 10. -10, 0, and positive 10. Okay. Here's where I have my one exception, because we're saying what multiplies to 25 and adds to -10. That would be -5 and -5. So we're going to factor to square root of x squared is x times x, right? And we have -5 minus 5 equals 0. Set them both equal to 0. They're the same thing. Add 5, x equals 5. Add 5, x equals 5. So here, this is a perfect square trinomial, and there's only one -5, positive 5, sorry. One positive 5 on a number line. So we don't need to write that twice, because we're asking what are the solutions, and there's only one 5. So if it's the same thing, you only write it once. Because what we're looking at here is when we what we're finding and solving right here, right now, is if this is what, when we are graphing x squared, it makes a parabola, and what we're finding is where the parabola crosses the x-axis, and there's only 1, 5, and that is right here. So this is where it would actually be crossing. It kind of touches on it. All these others, this is not a parabola number 3 because it's x cubed. This is touching in 3 different places, at 0, at -10, and at +10. It's kind of like a squiggly 0, -10, and +10, something like that. So that's what we're finding here on the graph. With the perfect square trinomial, it happens to be where it just touches. They sit on the x-axis. Okay, and why we have 2 solutions normally is because when you're drawing that parabola, 2 solutions, if it's an x squared, it's crossing at both those places. So that's why we're solving these, to figure that out. That's why we've been factoring, to be able to solve these. Okay. Oops. Okay, so here we go, more factoring. Why don't you try this one on your own? Let's check it. So I'm going to factor out my GCF A, and then I'll be left with a squared plus -9. I'll do a times the quantity of a plus 3 times the quantity of a minus 3, because it's a difference of squares, right? Set them all 3 equal to 0. A equals 0, a plus 3 equals 0. I guess if it's a one-step, you won't have to show me -3, but if it's 2-step, anything more than a one-step equation, I do want to see the math for it. A minus 3 equals 0. So I guess you could just jump right here and go a equals -3 equals 3. Okay, now this kind of factoring, remember, is there a GCF? No. So it's lead coefficient factoring. Pause the recording, try this one on your own. All right, let's try it. I'm going here, I'm multiplying by 6, so what multiplies to, usually I'd put it to the right, but I don't have enough room. Don't put it all in the middle of the problem, put it to the right, to the left, keep it close. What multiplies to 60 and adds to 11? 6 and 10. So I'm going to start taking my, let's go 60. I've got 1 and 60. Oh, I know what it is. 2 and 20. I think it's 15 and, oh, it was a -60, yeah. I think it's 15 and 4. 15 and 4. Let's see. X squared plus 11x minus 60 equals 0. So 15 would have to be positive since it adds to positive 11. So here we go. I'm doing x minus 4 times x plus 15 equals 0. But remember, we have to, don't forget, divide by 6, divide by 6. I have to reduce them first. 2 goes into that twice, and 3 times we get 3x minus 2. 3 goes into that 5 times, and twice I get 2x plus 5 equals 0. Now I'm just going to do, that's a 6x squared. That's -10. Here's 4x. Here's positive 15x. It works. Okay? Always double check my factoring. Now, these I expect you to set equal to 0. So 3x minus, I should say that all that goes with that. 3x minus 2 equals 0, and 2x plus 5 equals 0. So I'm adding 2, I'm adding 2. We always undo the addition and subtraction first. 3x equals 2, divide by 3, and x equals 2/3. Subtract 5, 2x equals -5, divide by 2, and x equals -5/2. Okay, so my solutions here are -5/2 and 2/3. Okay, questions? So you see, once I have anything more than a one-step equation, we're showing the math for it. -5/2, 2/3. All right, what happens if it doesn't equal 0? Well, we have to manipulate it and make it equal 0. So I'm doing the inverse operation, 45n. Then I have to do my GCF of 5n. I'm left with n squared plus 6n plus 9. I have to factor n squared plus 6n plus 9, which you can either do your x marks the spot, or if you know that it's a perfect square trinomial, then we know it's plus 3 plus 3. So it's 5n times n plus 3 times n plus 3 equals 0. So 5n equals 0, n plus 3 equals 0, n plus 3 equals 0. So here, I divide by 5, and n equals 0. Here, n equals -3, and n equals -3. I don't know. If you can do the math, I suggest, because too many people get too messed up on the negatives, positives, so you don't have to think about it if you're doing the inverse operation. So my solutions are -3 and 0. I do not write that twice. Next one. Pause the recording if you want to try that on your own. We're going to subtract it, set it equal to 0. Move it so your x cubed is positive. So I'm going to subtract the 49x from both sides. Now it's equal to 0. I can use my zero product property. I'm going to GCF an x out, 1x. Now what I'm left with is a difference of squares. And so I don't need to do my x marks a spot right here. I know that the difference of squares. Okay, the square root of that is 2x. The square root of that is 7, so it's plus 7, and 2x minus 7 equals 0. Set them all equal to 0. And as I mentioned, if it's more than one step, x equals 0, 2x plus 7 equals 0, 2x plus 7 equals 0, subtract 7, 2x equals -7, divide by 2, and x equals -7/2, and x equals 0. We don't even need to do that one. I will trust that since they're exactly the same. So x equals -7/2. So my solutions always go here, -7/2, comma 0. Close the braces. Okay, let's try a couple more. Set them equal to 0, subtract the 18x. Try and make it smaller with a GCF. I'm going to divide 3 out of all terms. And then I'm left with this. Okay, it makes it much easier to factor. What multiplies to 8? What multiplies to 8 and adds to -6? So -4, -2. So I get 3 times x minus 2 times x minus 4 equals 0. Now, 3 is no longer a factor. We could have done two things with 3. When I was here, and I had x squared minus 6x plus 8 equals 0. Because 3 is not a variable, it's just going to sit there. So I could have actually divided both sides by 3 and made it disappear. You never want to make a variable disappear, though. X squared minus 6x plus 8 equals 0, because it's not going to become a factor in our solution. It can't equal 0 here. So I'm going to just kind of let it sit there, and the only thing I'm going to do is set x minus 2 equals 0, x minus 4 equals 0, and so here x is equal to 2, x is equal to 4, and 3 is just not really a factor. It sits there because it can never be 0. Okay? So my solutions are 2, 4. I always forget. Okay, yeah. But I could have divided it out. It still would have been the same solution. X minus 2, x minus 4 equals 0, x equals 2, x equals 4. Okay? So it doesn't matter if you take that lead, that GCF, and let it hang out there, or if you want to divide it out, that's fine too. Okay, whoa. Okay, let's set this equal to 0. Why don't you guys try this one? Pause it. Set it equal to 0, and then factor it. Now let's try it. Subtract by 0. We're going to have some lead coefficient factoring. 4 times 3 is negative 12, and I have negative 11. So how about negative 12 and 1? So we get x squared minus 11x minus 12 equals 0. We're factoring that to x plus 1 times x minus 12 equals 0. Do not forget to divide out. We multiplied by 4. We have to divide by 4. Okay, so the first one's going to become 4x plus 1. The second one is x minus 3. I'm going to double check that. This times this equals 3, negative 3. This times this equals 4x squared. And then 1x and negative 12x. If I do that equals negative 11x, so it works. I'm going to set this one for x plus 1 equals 0, subtract 1. 4x equals negative 1, divide by 4. And x equals negative 1 over 4. And x minus 3 equals 0, add 3, x equals 3. Okay. So x equals negative 1 over 4 and x equals 3. Those are my solutions. Negative 1/4 and 3. We always put them in a solution set. Let's see what we got. And that, my friends, is our lesson.